Good morning and welcome to Algebra for Tuesday, May 26th. Well, we've finished graphing the quadratic equation in all three forms. You gave me your test materials. Hopefully you got the grade that you were hoping for. Let's talk about how we solve these problems. So here's a fact for you. All right? The x-intercepts, the places where the parabola crosses through the x-axis, those are actually called the solutions to the quadratic equation. So if you're trying to solve for the quadratic equation, it's actually the x-intercepts that are the answer we're looking for. It's really easy if you're asked to solve for the quadratic equation when the problem is in intercept form. It shows you what the answers are, which is really, really easy. However, obviously, it's not always in intercept form. We have vertex form and we have our standard form as well. So how do you solve the quadratic? Let's just assume you're not being given intercept form, because if you were, there's no work to do. So let's take an example where we have a quadratic equation and it's in standard form. We already know that we can graph a quadratic equation and we can see where it crosses the x-axis, and I just told you that that would be the solution. So let's take that approach here. So in this case, a is the number 1, b is -6, and c is 9. And I taught you how to find the vertex of the quadratic by using the little formula of x equals -b over 2a. Which is -6 over 2 times 1, which is 6 over 2, which is 3. And then we plug in 3 as an x value to determine what the output would be. Y equals 3 squared minus 6 times 3 plus 9. That's 9 minus 18 plus 9. 9 minus 18 is -9 plus 9 is 0. So the vertex of this parabola is at the coordinate 3, 0. And then we would continue to make a t-table so that we can graph the quadratic equation. So here's my t-table. Going to put 3, 0 in the middle. We'll count backwards, 2 and 1. We'll count forwards, 4 and 5. And we'll plug in the numbers 1 and 2 and then reflect it with the other two outcomes. So if I plug in a 1, I'll just put that over here. 1 squared minus 6 times 1 plus 9. 1 minus 6 plus 9. 1 minus 6 is -5. -5 plus 9 is 4. So that's a 4. And I'll try 2 also. 2 squared minus 6 times 2 plus 9. 4 minus 12 plus 9. 4 minus 12 is -8, plus 9 is 1, and they'll reflect. And then I can graph it and see what my x-intercepts are. So we have to go 1, 2, 3, 4, 5 on the x, and up to 4 on the y. And we have 1, 4, 2, 1, 3, 0, 4, 1, 5, 4. Looks like it just touches right there. There's only one x-intercept and it's at 3. So the solution to this problem is x equals 3, because the solution to the problem is where the parabola would touch or cross the x-axis. It's a long way to go. It's also not the most accurate thing we can do because there's other problems that are inherent in graphing. Obviously, you guys have all come across those issues because there have been some confusions along the way. So let's find a better way that doesn't take this much time and work and also still leave room for error. I mean, what if it crossed on a decimal? What if you couldn't tell? These are definite possibilities. So there's a better way. Before we get to the actual better way, how many solutions can there be? Let me just take a look here real quick. If I give you a parabola, we just saw one that touches the x-axis, and as I like to call it, it kind of bounces off. So like a ball, it comes down, it hits the x-axis and bounces off. So how many solutions were there when that occurs? There's one solution in a parabola that looks like this. One solution is where it's crossing the x-axis. Previous problem, the answer was 3. But parabolas can also cross more than one time if they go all the way to and through. Like this parabola crosses twice. A parabola that crosses through the x-axis and keeps going, and then turns around and comes back up or down through the x-axis, has 2 solutions, which is one of the most common types of parabolas you'll see. But there's also the possibility of a parabola that doesn't ever cross the x-axis. It could be like that, it could be over here. Doesn't matter. It could be anywhere. But these 2 parabolas, they never get to the x-axis. So how many solutions are there to a parabola that will never cross the x-axis? 0. A parabola that does not cross the x-axis, it has 0 solutions. So there's really 3 possibilities here for every parabola. They'll either have no solution because they don't cross the x-axis, or they'll have 1 solution because they hit the x-axis and then bounce off, kind of like deflecting, or they'll have 2 solutions because it'll cross through the x-axis, move on, turn around, come back up and cross through again. Okay? That's the number of solutions we could find. The answers themselves are the places on the x-axis where that intersection occurs. All right. Here's I'm going to say the easiest way to solve a quadratic equation. It does require the use of a formula, which you'll have to remember, and I'll teach you a little trick to do so. This is called the quadratic formula. The quadratic formula is an equation that we can use to solve for the intercepts of any parabola. It's not that hard an equation, especially since we're distance learning and you can just use it and have it next to you when you answer questions. You don't have to technically memorize it right now because I'm not watching you. Here's the formula, and I'll teach you a way to remember it. All right, it's on the board. We already know from standard form that there will be an A, a B, and a C value. They're not hard to find. The quadratic formula shows you how to set them up so you can find the 2 or 1 or no places where a quadratic equation, parabola, will cross through the x-axis. Now, I'm sure that I will regret doing this, but I'm going to sing you a song to teach you how to remember the quadratic formula. It's sung to the tune of Pop Goes the Weasel. So here's me recording for you and the internet, which I know I'll regret, how to remember the quadratic formula. Ready? X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Yep, that's right. I sang for you. Then you can rewind that and you can play it again and again and again. Share it with all your friends. But that's how you can remember the quadratic formula. It's not that hard. And again, you're distance learning. You could just be looking at it during your quiz, your test, your whatever. But eventually, we will one day go back to school and you'll be expected to remember that formula, especially for Algebra 2. Let's use it and see how it works. Okay. So I'm going to give you an example and then we'll solve with the quadratic formula. I'm going to erase this for right now so that we can have room for our work. Here's an example for you. Ready? Okay. Where did my example go? There it is. So, y equals 2x squared plus 7x plus 3. Okay. There's your parabola. There is your standard form. Let's first identify a, b, and c. We know we're going to need them. A is the number 2. It's the first coefficient of the x squared value. B is the number positive 7. It is the coefficient of the x value. C is the number positive 3. So far, so good. The rest is really just substitution and solving somewhat carefully. So, x equals negative b. Well, b was 7, so it's negative 7. If b were a negative number, it would turn positive. So, x equals negative 7, x equals negative b, plus or minus the square root of b squared. Well, that's 7 squared. Minus 4 times a. Well, a is the number 2. Times c. C was the number 3. All over 2 times a, which was again the number 2. And here it is again. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now let's solve carefully. That's negative 7 plus or minus, we'll have to do both incidentally, the square root of. 7 squared is 49. Negative 4 times 2 times 3, well, that's negative 8 times 3, which is negative 24. And it's all over 2 times 2, which is, of course, 4. 49 minus 24. Well, 49 minus 24 happens to be 25, all over 4. Now, I chose an example that does have an easy-to-find square root. There can and will be problems that will have decimals here. You'll have to just use your calculator. The square root of 40. It's not going to be a perfect square, so it's not going to be a whole number. You'll just round to, let's say, 2 decimal places. This one's a perfect square. The square root of 25 is 5. So this is x equals negative 7 plus or minus 5 divided by 4. Now, there's a reason why it's plus or minus. There will be 2 solutions. It's a parabola that crosses through the x-axis and comes back around. So there will be just 2 answers. So we have to solve 2 problems, really. So here's what I'm going to do. I'm going to show you over here. I'm just going to make some room. I have x equals negative 7. I'll take the plus first. Plus 5 over 4. I'm taking the plus first. I will also have to do the minus. And that's going to be negative 7 plus 5 is negative 2 over 4. And that's negative a half. Okay? That's one of my solutions. But I also have to do the other aspect of it. Negative 4 minus 5 divided by 4. Negative 7 minus 5 is negative 12 divided by 4. And that's negative 3. So I found the 2 places on the x-axis where that parabola would cross. Negative a half and negative 3. Now understand, you might not actually be able to graph that and tell that negative a half is truly the number where it's crossing through. It's way too hard to graph to tell, but it's not that hard to use the equation. Okay? So, this is our first example, and we will just be happy that it was solved without too much stress and concern. If you wanted to verify, and you happen to have a graphing calculator, or let's say you have Desmos, because everyone's got access to Desmos, you could graph it, and let's just see, 2x squared plus 7x plus 3, we'll graph it. I'm looking for the x-intercepts to be negative 3 and negative a half. I don't know if you can see all that well, but it looks to me like it is crossing the x-axis at negative 3 and negative a half. It is. So I feel good about my answer. Now, there's no homework. There are complications that we're going to run into as we move through this unit. And for that, I just want you to understand quadratic formula, what it tells you, and how many solutions there can be. So, that's all for today. There is no homework for tonight, but please watch tomorrow's video and there will be an assignment. Have a great day.